Hello, this is Mr. Collier, and today we're doing geometric sequences. So firstly, what is a geometric sequence? Well, in an arithmetic sequence, we're adding the same value each time to get our terms. In a geometric sequence, you're multiplying each time to get your new terms. So in a geometric sequence, like say if we have this sequence, 2, 4, well that's just times 2, so we can keep multiplying by 2. And that's a geometric sequence because you're multiplying by 2 each time. Okay, so that number that you're multiplying by each time has a special name. That's called the common ratio. And we call it R. Okay, so that R is going to come into the formula we're going to derive in a second. So our first term here is 2, so that's like the first term is u sub 1. And let's take a look at 16 over here. That's the 1, 2, 3, fourth term. And that's u sub 4. So let's look at how we get u sub 4 if we just know u sub 1 and the common ratio. So how did we get from 2 to 16? Well, we multiplied by 2 3 times. Okay, so we did 2, which is the first term. Then we multiplied by 2 3 times. So that's 2 to the power of 3. Okay, and this 2 comes from R, it's the common ratio. So our formula for u sub n is going to be u sub 1 times R, and this 3 is actually 1 less than the term number. So the term here is 4, but our power of the common ratio is 3, so it's 1 less than the term number. So this is going to be R to the power of n minus 1. So that's your general formula for finding a term in a geometric sequence. So let's check if this works out. So the next term in the sequence, the u6 term should be 64. If I multiply by 2, I get 64 here. So let's check our formula. U sub 6 equals, now u sub 1 is 2. The common ratio is 2. And 6 is n, so n minus 1 is going to be 5. So we're going to have 2 times 32, which is exactly what we predicted we'll get, 64. So this formula works for finding the nth term in a geometric sequence. So let's look at a couple of examples. In this one here, find the next two terms in each geometric sequence. So we know this is a geometric sequence. We know we're multiplying by 2 each time. So you just times by 2 again. You get 12, times by 2 again, you get 24. Okay? Now here, what do you multiply 16 by to get 8? Sometimes it's not so obvious. You can always get the common ratio by doing this. If you multiply by r, you get the next term. But if you want to get the common ratio, you can divide a term by the previous term. So the common ratio is equal to 8 divided by 16, which is equal to half. Which makes sense because half of 16 is 8. Then you're going to do half of 8, which is 4, and then half of 4, which is 2, and so forth. Okay, so let's take a look at another example. Show that 2, 6, 18, 54 is a geometric sequence. To show that, we need to show that the ratio is the same all the time when we're dividing a term by the previous term. So we need to take 6 divided by 2. What does that give us? It's 3. We need to take 18 divided by 6 is 3. And if you do 54 divided by 18, you also get 3. So r equals 3, and therefore it is a geometric sequence. Okay. Nextly, find u sub n and hence find the 10th term. So our formula is u sub n equals u sub 1, which is 2, and times the common ratio, which is r, in this case is 3, to the power of n minus 1. So there's our formula for finding any general term in the geometric sequence. And we're asked to find a 10th term. So u sub 10 equals 2 times 3 to the power of 9. And so let's work that out using our calculator. 2 times 3 to the power of 9 is 39,366. 39,366. Okay, let's look at another example. Show that this sequence is geometric. So again, we have to divide successive terms. Negative 32 divided by 64 is negative half. If we do 16 divided by negative 32, you get negative half. And negative 8 divided by 16 is negative half. So therefore, it is geometric. Okay, next we have to find u sub n. So u sub n is equal to u sub 1 times r to the power of n minus 1. And that is going to be, well, u sub 1 is 64. And then you multiply by the common ratio, which is negative half. So you get negative half to the power of n minus 1. Okay, so next, you want to find the 9th term. So u sub 9 is going to be equal to 64 times negative half to the power of 9 minus 1, which equals 64 times negative half to the power of 8. Okay, so let's work that out on the calculator. So let's do 64. Let's do 64 times, and let's put in negative half to the power of 8, and we get 0.25. So here we get 0.25. 0.25 is the 9th term in the sequence. Okay, in the 4th example, we have k minus 1, 2k, and 21 minus k are consecutive terms of a geometric sequence. Find k. Well, in a geometric sequence, we know that if we divide successive terms, we get the common ratio of r. So they should be equal to each other when we divide the consecutive terms. So 21 minus k out of 2k should be equal to 2k out of k minus 1. And then we're going to cross multiply. So we get 4k squared equals 21 minus k times k minus 1. And let's multiply that out. We get 21k minus 21 minus k squared plus k. And simplify a bit more. That's 22k minus 21 minus k squared. Okay, so I can, well, one thing I could do is I could subtract 4k squared from both sides, and I will get 0 equals, let's write the k squared first. So that's negative 5k squared plus 22k minus 21. So we have a quadratic equation. There's a couple ways to solve it. What we're going to do is we're going to find the two solutions using graphing calculator. So our values in front of the coefficients are negative 5, 22, and negative 21. We're going to use a graphing calculator to find the solutions. So we go to Programs or Apps and find Polysmult. It'll help you find the solutions. Maybe you have polysmalt 2. Use that as well. So I'm going to go to polynomial root finder. And the degree of the polynomial is 2 because it's k squared. And then we just put in these values here. So it's -5, enter, 22, and -21. And then click over here for solve. And we get our solutions are 1.4 and 3. So we have 1.4 and 3 are the